I'm Anil Kumar, and here is solution of question number 13c, page 106, Nelson, Vectors and Calculus. I hope my subscribers will benefit from this solution. The question here is, determine derivative at a given point, y equals to u times u square plus 3 whole cube, where u is equals to x plus 3 whole square and x is minus 2. So whenever we have function of function, we need to apply the chain rule, and remember dy dx is actually equals to dy, in this case, since it is defined in terms of u, dy du, and du dx, since u is defined in terms of x, so du dx. That should give us a solution. Now another thing which we have to look into is we are given the value of x as minus 2. We don't know what u is. So let us also find what u is. So u is equal to x plus 3 whole square. Now x is given to us as minus 2. Let us substitute that here. So we get minus 2 plus 3 whole square, and that is equals to 1. That means u equals to 1 when x equals to minus 2, right? Now using these two functions, we can find the derivative of y with respect to u and derivative of u with respect to x. So let us do that now. So I'm just dividing it into two parts. We'll find derivative of each. So u is the inside function, u equals to x plus 3 whole square du dx is equals to 2 times x plus 3 times derivative of inside function, which is 1. We need to find this derivative at x equals to minus 2. So it is useful to really calculate or evaluate this derivative at x equals to minus 2. So we can substitute minus 2 here and find the value. So that is equals to 2. This will help us in simplification, right? We really don't have to simplify. If we do this step, then we save a lot of time. Now here we are given y is equals to u times u square plus 3 whole cube. So we'll apply the product rule here, right? So we get dy du equals to derivative of u is 1. So I'm not writing 1. So derivative of u is 1. We are using the product rule. I hope you remember what product rule is. If we have u and v, then the derivative of their product is derivative of u times v plus u times derivative of v, right? So we are applying this product rule and writing the solution. So derivative of u is 1 times you have u square plus 3 whole cube plus u times derivative of the second function, which is times 3 u square plus 3 whole square times derivative of inside function, which is 2u, correct? 2u. So that is how we find the derivative of the first function, right? So let me rewrite this. We'll multiply these terms, kind of simplify. Then we'll substitute u as equal to 1 in this expression. So we have u square plus 3 whole square plus 2 times 3 is 6. U times u is u square. And we have inside bracket u square plus 3 whole square, right? So I just squeezed it in. Now let's find the derivative of y with respect to u when u is equals to 1, right? So u equals to 1. Substitute 1. So what do you get? 1 plus 3 whole square plus 6 times 1 is 1. And here we get 1 plus 3 whole square, right? I'm sorry, this is cube. Yeah, it's cube. Okay, that will make huge difference, right? So the first term was derivative of u times the second term, which is u square plus 3 whole cube. So I should have had cube here, which I have now. And the second term is u times derivative of u square plus 3 whole cube, which is 3 times this number square times derivative of inside, which is 2u, right? So let's calculate. 1 plus 3 whole cube, it is 4 cube, which is 64, plus 6 times 4 square, which is 16. But anyway, you should use calculator, right? So we have calculator here, 4q plus 6 times 4 square. So 160. So we get this value as 160, right? Now what we need to find? We need to find the derivative dy dx at x equals to minus 2. At x equals to minus 2. This is equals to dy du at u equals to 1, that is x equals to minus 2, times du dx, right, at x equals to minus 2. So let's substitute these values. The first one for us is 160, right? And the second one is 2, so times 2, correct? So we get 320 as our answer. So 320 is the derivative of this function at x equals to minus 2. So these are the steps involved. I hope they're absolutely clear. Go through them once again, and I hope that helps. Thank you and all the best.